Current part 1. In this, the topics which I am going to discuss are current, Drude and Lorentz theory, drift speed, and potential difference. These topics I am going to discuss in a detailed manner. First, let us see what is current. Current. Current is nothing but movement of electrons in any object. In any object, if you can move the electrons, then current is said to pass through it. So any material which is able to move the electrons can pass electric current. Any material which is able to move the electrons can pass electric current. Such materials which can conduct electricity easily are called as good conductors of electricity. Any material which is not able to move the electrons cannot pass electricity. Any material which is not able to move the electrons cannot pass electricity. Such materials are called as bad conductors of electricity or insulators. Let me explain you this with an example. Here I am taking two elements, sodium and ethane. First let us see sodium. If we go through electronic configuration of sodium, its electronic configuration is 1s2, 2s2, 2p6 and 3s1. Till here 1s2, 2s2, 2p6, this is completely octet configuration. The electrons which are present in octet configuration will not participate in any process, whereas we have one free electron 3s1. 3s1, this is a free electron, and here if we can able to move this free electron in sodium metal, then current will pass in sodium metal. Hence sodium is a good conductor of electricity because it is containing free electron. It can move freely wherever we can move it. Whereas if we come to ethane, if we go through structural formula of ethane, in ethane molecule all the electrons are participating in bonds and they are tightly involved in the bond formation. So here in this structure there is no free electron. We cannot observe any free electron in ethane molecule. Hence ethane will not conduct electricity at any cost. Hence it is a bad conductor of electricity. From this we can conclude that any element which is having free electrons is good conductor of electricity. Any element or any material which is not having any free electron, then it is bad conductor of electricity or insulator. These are the wires which you observe in your houses regularly. Red color wires, green color wires, black color, yellow color. All these wires contains inside copper material. This is a copper metal. Since copper metal is having large number of free electrons, it will conduct electricity easily. Whereas outside this red, blue, green, yellow colors which you see is a insulation coating. That is a insulation coating, whereas actual conducting material will be inside of that insulation, that is copper. These are the some of the examples of electrical conductors. Most of the metals are electrical conductors because they have free electrons, and silver is the best conductor of electricity. After that gold, copper, steel and seawater is also good conductor of electricity. Whereas insulators are materials which are not having any free electrons to conduct electricity. In order to conduct electricity, we need definitely at least one free electron. If that material is not having one free electron also, then it cannot conduct electricity. It means that material is a insulator. For example, previously I explained you ethane molecule. All the electrons present in ethane molecule are participating in bond formation. They are tightly packed in the molecule, hence free electrons are not present in that molecule, and hence it cannot conduct any electricity. Similarly, all organic compounds, either linear chain molecules or cross-linked molecules, are bad conductors of electricity. For example, rubber is also a organic compound. It is not having any free electron, that is why it cannot conduct electricity. Glass is also an organic compound, and oil, diamond, all these materials are not having any free electrons, that is why they cannot conduct any electricity. Now, in order to explain how metals are conducting electricity, there is one famous theory called Drude and Lorentz theory. Drude and Lorentz, named scientists, proposed combinedly a theory called Drude and Lorentz theory in order to explain how metals conducting electricity. So according to Drude and Lorentz theory, in any material, in order to conduct electricity, there should be free charge carriers. There should be free charge carriers. These free charge carriers may be positive charges or negative charges. If we have any free charge carriers like positive charges or negative charges in the sense electrons, positive charges in the sense protons, any free charge carriers are present in the material, then that material can conduct electricity. In metals, there will be large number of free electrons, and hence electrons are charge carriers in metals. Whereas in case of fluids, say example electrolyte like NaCl, in case of NaCl, if we pass electricity through NaCl, NaCl will be dissociated into Na plus and Cl minus ions. In this case, both positive and negative charges will conduct electricity. So this theory says that metals contain large number of free electrons. When metal is not conducted to the battery, all the free electrons will be moving randomly in different directions they want. If you take any material which is made up of metal, say for example copper or sodium or magnesium or silver, any wire, cylindrical wire is made up of a metal, then it contains large number of free electrons. These free electrons will be moving randomly in different directions they want before it is connected to the battery. When it is not connected to the battery, when this metal is not connected to the battery, these free electrons will move randomly in different directions they want. Now if we imagine any cross section, number of electrons moving from left to right is equal to number of electrons moving from right to left. If we imagine any cross section in this material, number of electrons moving from left to right is equal to number of electrons moving from right to left. For example, say from left side to right side, if 10 electrons are moving, then same number of 10 electrons will move from right to left. So hence net charge passing through this cross section is 0, because from one side if 10 electrons are moving, then to the other side also same number of 10 electrons will be moving. Then as a result, this 10 and 10 will get cancelled, and net charge passing through this cross section will become 0. When net charge is 0, then current is also 0 when this is not connected to the battery. But when conductor is connected to the battery, an uniform electric field is set up throughout the conductor. which makes the electrons to move only in specified direction. For example, when this is connected to the battery, when we are connecting it to the battery, it means one side we are creating positive terminal, and another side we are creating negative terminal. So one side it is positively charged and another side it is negatively charged. So whatever electrons are present in this metal, whatever the free electrons present in this metal, and we know that these electrons are negatively charged particles, that is why these electrons will get repelled with this negative charge. That is why these electrons will get repelled with the negative charge, and they start moving away from the negative, and they will get attracted towards the positive charge, and they will start moving towards the positive charge. In this way, all the electrons will start moving from negative terminal to positive terminal. Now if we take any cross section, now at this cross section, all the electrons are moving only in one direction, that is from right to left. No electron is moving in left to right. In this direction, no electron is moving. All the electrons are moving only in one direction, that is from right to left. Hence, net charge in this will not be. Hence, net charge in this metal when it is connected to the battery will not be zero. It means all the electrons are moving in a ordered motion. All the electrons are moving in only one direction, that is from negative to positive, because electrons will get repelled by negative terminal and they will get attracted by positive terminal. That is why all the electrons are moving in only one direction, in only specified direction, that is from negative to positive. That is why now in this case current will pass in this conductor. This ordered motion of electrons is nothing but current. So current is nothing but ordered motion of electrons. So if we are able to move the electrons, then current is said to pass in that material. Now when electrons are moving in a metal, from the previous discussion, it is clear that electrons will be moving in a metal. It means that charge is moving in a conductor. When electrons are moving from one place to another place, it means charge is moving in that conductor. Direction of movement of electrons is always from negative to positive, because electrons are negatively charged particles. They will get repelled by negative and they will get attracted by positive. That is why direction of movement of electrons is from negative to positive. This is very important, you need to remember. Whereas direction of the current is always from positive to negative. Direction of the current will be opposite to the direction of the movement of the electrons. This is the standard recognition. You need to remember this. This is the standard representation. Electrons will move from negative to positive, whereas current direction in standard case, in standard representation, we will take direction of the current as from positive to negative, that is opposite to the direction of the movement of the electrons. Hence, from this we can conclude that electric current is defined as amount of charge moving per unit second. Per unit second, what is the amount of the charge moving through the cross section? That is nothing but current. Current is nothing but charge per unit time. And units of the current is charge by time. Charge units is coulomb, and time units is second. So units of current is coulomb per second. This one, it is standardized as 1 ampere. 1 ampere is 1 coulomb per second. So if any material allows the current to pass through it easily, then it is called good conductor of electricity. Examples are silver, copper, iron, and most of the metals. If any material does not allow the current to pass through it, then it is called insulator. Examples are plastic, rubbers, glass, and most of the carbon compounds, organic compounds, linear chain compounds, cross-linked compounds, etc., which does not have any free electron in them. Now I would like to ask you a question, that is, if we have two current carrying wires of length 10 meters, one current carrying wire of length 10 meters and another current carrying wire of length 1 meter, and these two wires are connected to two different bulbs. Now when we switch on, which bulb will glow first? Do you think the bulb which is connected to 1 meter wire? But that is not the answer. Both the bulbs will glow simultaneously, because when we switch on, irrespective of length of the conductor, an uniform electric field is set up throughout the conductor instantaneously, irrespective of the length of the conductor. It does not depend on the length of the conductor. Whatever the length of the conductor, whether it may be 1 meter or 1 meter or 10 meters or it may be 100 meters, irrespective of the length of the conductor, current will be passed instantaneously throughout the length of the conductor, irrespective of the length of the conductor, and uniform electric field is set up. Because of this uniform electric field, current will be passed instantaneously and bulb will glow instantaneously, even though length of the conductor is 100 meters or 1000 meters or 1 kilometer also, bulb will glow instantaneously whenever we switch on, because of uniform electric field. This uniform electric field will make the electrons to move in a conductor, and hence bulb will glow instantaneously when we switch on. Next one is drift speed. Next topic is drift speed. Drift speed is nothing but average speed with which electrons move in a conductor. Till now we have seen that current is nothing but movement of the electrons in a conductor in specified direction. So here, from the previous discussion, it is clear that when we connect any conductor to a battery, electrons will move in that conductor from one place to another place. So when electrons are moving, they will be having some specific speed. That speed, average speed of the electrons, is nothing but drift speed. It is denoted by Vd, and drift speed is given by the formula Vd is equal to I by Nqa. I by Nqa, where I is current, N is number of electrons, Q is charge of electron, and A is cross section area. Now if we take a copper conductor of 1 millimeter square, and if we pass current of 1 ampere, then number of electrons moving in that copper conductor is experimentally found out to be 8.5 into 10 power 28, and we know that charge of the electron is 1.602 into 10 power minus 19. By substituting all these values in the formula Vd is equal to I by Nqa, we'll get drift speed of electrons in a copper conductor when 1 ampere current is passed is 0.07 mm per second. When 1 ampere current is passed in a copper wire, then speed of the electrons with which they move is 0.07 mm per second. Now let us see about potential difference. So in order to explain potential difference, I would like to tell you one small example. So potential difference here, I would like to say that potential difference is nothing but the driving force which makes the electrons to move from one place to another place in a conductor. In a conductor, if we take a conductor which is made up of any metal, it will have large number of free electrons. It will have large number of free electrons. These free electrons, they will not move from one place to another place without connecting to the battery. Without connecting to the battery, these free electrons simply they will not move from one place to another place. Whenever we connect it to the battery, only then these free electrons will move from one place to another place. That whenever we are connecting it to the battery, then this battery is creating some potential difference between the ends of the conductor. This battery is creating some potential difference between the ends of the conductor. That potential difference is making the electrons to move from one place to another place. So here I would like to say that potential difference is nothing but driving force which moves the electrons from one place to another place. Potential difference, so when we are applying potential difference, it means we are applying one side negative, another side positive charge. So electrons are getting repelled by negative terminal and getting attracted towards positive terminal. Because of this negative and positive terminals only, electrons are moving in specified direction, and hence current is passing in this conductor. It means without applying potential difference, we cannot pass current in this conductor. It means I would like to say that potential difference is nothing but driving force which moves the electrons and which makes the current to pass through it. For example, I would like to say through an example, that is, when we hold a battery between our fingers, we will not get any shock. Whereas if we keep our fingers in a switchboard, from this image you can see we will become like this. We will get huge amount of shock. So what is the difference between these two cases? In the first case, when we hold the battery between our fingers, even then also current will pass through our body, but it is very less amount. It means this, when we are holding battery between our fingers, battery voltage is very less, potential difference of the battery is very less, that is 1.5 volts or 3 volts or 5 volts, or it may be sometimes 9 volts. This 9 volts is not at all sufficient to move the electrons present in our battery, present in our body. Whereas when we keep our fingers in the switchboard, then the voltage or potential difference whichever present in that switchboard is 220 volts. Such high voltage, such high potential difference is making the electrons present in our body to move from one place to another place. Then huge amount of current is passing in our body, then we are getting shock. It means here the potential difference is the driving force that makes the electrons to move. In the first case, since potential difference is very less, that is why the electrons which are present in our body are not moving, hence we are not getting any shock. Whereas in the second case, since potential difference is very high, the electrons which are present in our body are moving and current is passing through our body and we are getting shock. It means potential difference, remember that potential difference is the driving force which moves the electrons. It means potential difference is moving the electrons. It means potential difference is doing some work on the electrons. This work done by the electric force on unit positive charge to move it through a specified distance from point A to point B is called potential difference. Potential difference is nothing but work done by the electric force to move the positive charge from one place to another place is called potential difference. It is also called as voltage and it is denoted by V. and V is equal to W by Q, work done per unit charge. Work done is force into distance by charge. Its units are work done units is joule and charge units is coulomb. Joule per coulomb, which is called as volt, 1 volt. And voltage is measured by using device called voltmeter. Voltage is measured by using device called voltmeter, whereas current is measured by using device called ammeter. And remember two important points here. Ammeter should be always connected in series and voltmeter should be connected in parallel always. I'll tell you the reason in coming chapters in next part. In later case, I'll tell you the reason why ammeter should be connected in series and why voltmeter should be connected in parallel. In the coming sessions, I'll tell you the reason. So here you can observe the images of ammeter and voltmeter. This is how a ammeter looks like. Here this symbol A represents amperes. It means it is measuring the current in amperes, and in this voltmeter symbol V represents voltage. It means it is measuring voltage in terms of volts. Thank you everyone. I hope it's clear. Thank you.